Yes, thank you. Thanks the organizers also for staging this sessions today. So Clayton and Enrique has prepared the ground for my talk to some extent. And well, this is already the second transparency. So you see, I would like to start with two quotes about Max Born. The talk is on Max Born's grand plan on the impact of experiment on Max Born's research agendas both in Frankfurt and Göttingen. The first quote is by his wife. Max is very hard-working. His experiments finally work, and he sits in the institute until 8 p.m. and performs measurements. And the second quote is from a letter to Felix Klein, where Born writes, there are a number of doctoral students here engaged in experimental work, which I had suggested and whom I have to supervise. Strangely enough, I don't have any theoretical doctoral student. My talk will have two parts. One is about Born and Frankfurt, not very well known, the episode, I guess. The second part is about what is Born's grand plan basically for Göttingen. And the third part is about the collaboration between Born and Frank at Göttingen and what I have called the multiple avenues towards quantum mechanics. So I'm sorry this is the last talk of today, but I still will read a paper. After World War I, Max Born switched positions with Max von Laue in Frankfurt, a move that secured both a full professorship. In this process, Laue provided an assessment of Born, an elucidating account of Born's strength and interest in three different areas. First, Born had demonstrated his authority in the field of general relativity. Secondly, his publications on quantum theory had proved his ability to identify modern scientific problems and the means for their solutions on his own, as a case of the superior theory of specific heats of solids that he has established together with von Karman showed, and it proves the very good physical eye of Born that he had founded his considerations on the arrangement of atoms in space lattices at a time when the space lattice theory of crystals had not yet been demonstrated by experiments. And thirdly, and most importantly, Born would do research in a field Laue called electron theory, by which he was referring to Born's recent work on optical activity and liquid crystals. Laue stressed, I quote, that already a number of younger researchers had joined his research and Born himself was planning experimental investigations of these matters. Born's intentions to turn to experiment had thus become known. When Born completed negotiations with Frankfurt, he had not only become a full professor, he had also achieved everything he wanted, 3,000 marks budget for my institute, an assistant and a mechanic, as he wrote Landé. At the same time, he stated, I quote, I necessarily need an assistant who is not only able to do experiments with prepared equipment, but also can create a new apparatus. Therefore, I won't be able to give this position to you, namely Landé. The theoretical or even mathematical physicist, as which Born had widely been recognized, was now becoming a full physicist who naturally dealt with experiments, and he valued his experimental assistant, whom he still had to find, more highly than a theoretical one who was standing by. Otto Stern would become one of the new partners in this field for whom Laue had already arranged a lectureship at Frankfurt. Another was Walter Gerlach, the assistant of Richard Wachsmuth, director of the Physics Institute in Frankfurt. Gerlach, however, quickly felt more attracted by Born's physics. With Stern, who had a similar background like Born and who had also worked with Einstein, Born quickly became close friends. The impression that Born had brought quantum physics to Frankfurt can quickly be confirmed by his teaching activities. Both Born and Stern introduced a modern curriculum right from the start with courses on quantum theory, molecular theory, a joint seminar on quantum theory and lectures on relativity and atomistics for a broader audience. It was no easy task for Born to find an experimental assistant with the abilities mentioned. Eventually, the position was filled by Elisabeth Bormann, who had just completed her doctoral examination with Stefan Meyer at Vienna. She belonged to a new generation of female physicists who were given the opportunity to enter a scientific field mainly due to the war. Having attended practical classes with Exner and Meyer and a thesis on the experimental methodology of decay fluctuations, she had a thorough background in experimental physics. With Stern and Bormann as key collaborators, plus the mechanic Adolf Schmidt and Gerlach visiting in 1919, Born had established a strong experimental group, while Landé remained the only pure theoreticians at the department, with whom Born did not publish any further work from this point on. During the Frankfurt years, Born, however, co-authored 4 papers with Bormann, 2 with Gerlach and 1 with Stern, on 3 areas. First, the investigation of the real lattice structure of simple substances, in particular zinc blende. Second, Stern's idea to realize molecular arrays, which allowed for various experimental investigations of atomic physics. Like Born, Stern too had spent most of his time in theory, but now he was fully committed to examining fundamental theoretical concepts through experiments. He initially tried to verify, as we have seen this morning, Maxwell's velocity distribution, and he entertained plans for a molecular spectroscopy. Born and Bormann adopted his technology to detect cross-sections of molecule collisions in order to determine, for example, the diameter of the silver atom. These experiments occupied Born to great extent, as a quote of Hedwig Born to Einstein may have exhibited. Born, of course, did not convert fully to experimental physics, and his immersion did not get as far as, for example, Peter de Bays in Göttingen, but he made every effort to count as a full physicist who could combine theory and experiment for their mutual enrichment. Now, what about his grand plan for Göttingen? Also in Göttingen, the wind has shifted, mostly due to the war experiences and post-war needs, but clearly changes in the faculty also occurred. Hilbert's strong voice of support for theoretical and mathematical physics did not anymore get through so well. While Born had learned his lessons of applied science during the war work on atmospheric sound propagation and artillery ranging, he even had started supervising work by students on experimental physics. In Göttingen, he had to meet proponents of applied mathematics and their supporters from industry, led by Felix Klein. After Born received the Göttingen offer in May 1920, he went to see Robert Pohl first and had intensive discussions in order to define a plan for the arrangement of the teaching of physics that he then proposed to the ministry. In a 9-page letter, he took great pains to include all arguments to devise a full architecture of posts and duties. Recognizing Pohl's great experimental lectures, he still made clear that, quote, the theoretician also has the right to lecture 1 or 2 hours every week in the theater, for there are occasionally lectures that include demonstrations. Concerning the second position that Born wanted to give to James Franck, he had to walk a fine line between the claims of Pohl as a master experimentalist and the Göttingen Vereinigung championing technical physics. On the one hand, Franck would bring in his own approach to modern experimenting And with this, he was largely able to bridge theory and experiment. In addition, he had shared much of his career with Paul. On the other hand, however, Klein raised objections. Quote from Born, he fears that technical physics would come off badly if a pure physicist is called for Hermann Simon's position on applied electricity. Born told this to the ministry about Klein's opposition. The Göttingen Association for the Advancement of Applied Mathematical Physics could get one into trouble. Instead of drawing a rather artificial line between technical and pure physics, a distinction that is of no use when attempting to provide a broad education for their students, Born goes on, one should recognize, quote, there is only good and bad physics. Partly to appease Klein and the applied mathematics camp, partly to allow more personnel to be included, Born developed a detailed architecture both to span all fields of applied and experimental physics and to explain his elaborate space requirements. It involved Max Reich and applied electricity, Otto Stern to follow him suit from Frankfurt if he did not become his successor there, and Heinrich Rausch von Traubenberg, a lecturer who had shown good command of teaching in some major experimental courses in 1917 and 18. And here's even more from the, say, big teaching plan that even the practical classes were organized to a very, say, sophisticated structure. In the course of the differentiation of various kinds of experimental and applied physics, Born began to downplay his own experimental aptitude. I have never given experimental instructions, and I was able to get into this only when I abstained completely from my research work for several years, so Born told the ministry in his first long letter. This was, however, only the first sketch for a complete new program of physics teaching in Göttingen and marked the beginning of half a year of negotiations between Born, the two universities, and the ministry. Born's view on this matter was nuanced, and it was rooted in his relationship to experiments. As he had always stressed that he himself could not teach experimental physics the way Debye had done in Göttingen during the war years, he might have been willing to supervise doctoral students on experimental research as he has done in Frankfurt. When it came to fill the position of applied electricity, he opted for not asking a technician, but rather a physicist able to teach this field to students of mathematics and physics from a higher perspective. Here, Frank would have been an ideal candidate. It, however, was the Göttingen Vereinigung and the faculty that foiled this plan, and so he had to negotiate again with the ministry. Consequently, an arrangement was reached that made it possible to hire Frank anyway for an additional professorship. Putting his own interest in heading an independent institute for theoretical physics last, Born suggested that he would be willing to make a double sacrifice. Under the condition that Frank receive a second full professorship for experimental physics, Born would both forego the directorate in favor of Frank, and he would take on the full teaching load of theoretical physics alone. But in this way, he wrote, I acquire a collaborator with whom I share many common fundamental views, and I expect great advantages for teaching and research from this. Thanking Klein for supporting the appointment of Frank, Born wrote that he was fully aware of his responsibility for insisting on the very person, but he was quite sure that, quote, Frank would in fact be able to create a school of grand style. Like Faraday, Frank had the rare gift to recognize experimental opportunities, a fact that had been appreciated abroad before it was discovered at home. Frank would certainly help fulfill Klein's vision of science and industry stimulating each other. In October and November 1920, agreements with the ministry redefined Göttingen physics into 2 experimental departments for Pohl and Frank, with 2 assistants each, and a mathematical department for Born, with 1 special assistant only. Nevertheless, Born secured 20,000 marks for apparatus, a considerable amount, thus highlighting his continuing interest in experimental research. This appears less surprising given the fact that at the time Born was in the middle of his own experimental work in Frankfurt, and the Stern-Gerlach experiment was at a crucial stage. Born and his Frankfurt collaborators had just presented their experimental work prominently at the Naturforschertagung, which took place in Bad Nauheim in September 1920, historically remembered mostly for the dispute between Leonard and Einstein on relativity. Later that year, Born wrote Klein about his preparations to move to Göttingen for the spring semester, quote, "I'm very busy as it means a lot to me to finish an experimental project before my departure." And here is again from the Naturforscherversammlung that you can see there. It's a full paper of Born about all the experimental details and intricacies and problems of doing these experiments. And this is from the page of the Naturforscherversammlung, where you see that both Born and Frank are talking about experiments, while Lande is talking about the theory of atoms, of his quarter atoms. Now to Born and Frank in Göttingen. Born's move to Göttingen and his plan for a share of teaching labor, however, did not mean an end to an experimental research he had initiated in Frankfurt. On the contrary, a remarkable continuity can be found. When he wrote Gerlach in May 1921 that he really liked Göttingen and that his and Frank's assistants were busy assembling my apparatus quickly, with only liquid air missing. At the same time, he was arranging for the work of his old collaborators to proceed. In the case of his student Peter Lertes, who was now improving his experimental work for publication, Born made clear that he could easily duplicate his experimental work on dielectric fluids in Göttingen. "Please tell Lertes when he annoys you with his laziness, etc., I will have his rotation experiment built up in Göttingen. There are many people here who can handle amplifier tubes and could do the job quickly. One has to talk with the striplings à la entente with short notice ultimatums and sanctions." More cordially, Born praised Gerlach's energy to push forward crystal analysis, a project for which Born had provided the theoretical computations. Now he was working with him to figure out how well the atomic theory could be confirmed and where things still had to be changed. Commenting on a recent paper by Born's new Göttingen collaborator Frank, he and Gerlach compared various experimental and theoretical accounts of electron affinities, concluding that the fourth law, which describes the atomic repulsion within a lattice, needed refinement. Born was aiming at much more upscale X-ray equipment for Göttingen, and his closeness to Einstein was instrumental for gaining access to funding from the Kaiser Wilhelm Institute for Physics. As the details have been discussed by Gönner and Castagnetti, I just mentioned that Born, on the one hand, was strengthening his case by siding with Planck and Pohl, and on the other hand, was able to forego expounding definite research needs in the application, in this way winning the allocation of funds for no less than 100,000 marks. Thanking Einstein for the gift, he explained that such equipment, quote, "is now part of a reputable institute, and there are quite often questions that can only be answered with the help of X-rays. This grant donation means that all of you in Berlin are confident that we might figure out something respectable with the apparatus, which makes us happy." One line of experimental research that actually extended from 1920 up to 1925 and came from Frankfurt to Göttingen and with Otto Stern to Hamburg were atomic or molecular beams. When Born referred to my apparatus to be reassembled at Göttingen, he meant the experimental setup he had used for the determination of the mean free length of silver atoms with the help of Bormann. Although not much is known about the use of this equipment in the first years in Göttingen, a doctoral student of Born, Fritz Biels, explained at some length in the Physikalische Zeitschrift in 1925 how the, quote, experimental setup had been improved by Professor Born in cooperation with Hauser and Minkowski. These were the assistants from Göttingen and Hamburg, so that he was able to realize useful quantitative measurements, including the measurements of the diameter of an uncharged silver atom. Thanking Born for his suggesting and for supporting the execution of the project, and also the two mechanics of the Institute for constructing the somewhat complicated brass apparatus, Biels' dissertation is a good example for Born's continued interest in experimental atomic physics. Contrary to standard historiography, Born's program to systematically push forward Bohr's quantum theory for systems with few or many electrons was not a result of the 1922 Bohr Festival, nor did it coincide with his remark on competition towards Sommerfeld. Rather, it can be traced back to Born's late Frankfurt days, when Emmerich Brody assisted him to complete his book on atomic theory of the solid state. It was within this collaboration that both the problem of enharmonic oscillations and the use of perturbation theory adapted from celestial mechanics were brought to bear on quantum theory, both crucial resources on which Born later drew in work with Pauli and Heisenberg. Pauli's highly ingenious, though eventually unsatisfactory treatment of the simplest atom with two electrons, the hydrogen molecule ion, complemented efforts by Born and Hilbert. Both supervised Lothar Nordheim's dissertation on degenerate systems in quantum theory, and the very same problem of the hydrogen molecule ion who treated this problem in a different fashion. This line of research, Brody, Pauli, and after his departure also Heisenberg, led to some preparatory efforts and results which Born understood as the attempt to push the mechanical picture, the quantization, and the approximation methods to the very limit in order to recognize those elements of the classical theory that ultimately fail to provide appropriate models consistent with the experimental properties of real systems. Another experimental input which played a huge role in the discussion in Göttingen in the early 1920s was the Ramsauer effect. Originating from a rather different culture of physics, Philipp Lennert's and Heidelberg's Institute, the effect made Frank write to Bohr immediately after Ramsauer's talk at the Jena Physikertag that he was surprised, quote, "I am not able to believe, though I cannot show any mistake in the experiment. If this result is right, it seems to be, to me, fundamental." Born, in turn, told Einstein, quote, "This, however, is of interest because of this simply crazy claim by Ramsauer that in argon the free length becomes infinite with decreasing velocity. This, however, we would like to disprove." In this way, the Ramsauer effect contributed to bringing the problems of quantum theory at center stage in Göttingen, both to Frank, to Born, and probably also to the others. Here, this problem was tackled from both sides, experiment and theory. Frank's assistant Hertha Sponer had turned from theory to experiment on atomic collisions, and when she published results from her experiments, Friedrich Hund had just finished his dissertation with Born on a theory of the Ramsauer effect. Hund, however, was only able to present a qualitative derivation of the effect. It was at this stage, in particular, that Born started to attempt to solve the Ramsauer puzzle. With the help of Pascal Jordan, Hund's early qualitative results should be replaced by a sound and detailed treatment which hinged on a quantum theory of aperiodic processes. The extent to which the problem of the Ramsauer effect motivated research also illustrates the proposal by Walter Elsasser to perform diffraction experiments with free electrons according to de Broglie's dissertation. Initially a student of Franck's, who then turned to theory and to Born, Elsasser learned from both that such experiments had just been reported and that by and large the magnitudes would agree, so that he should rather work things out theoretically. Born and Franck, who were less interested in spectroscopy, for which the quantum theory of periodic processes was quite effective, but they were rather immersed in experiments of particle rays and molecular beams, thought it imperative to find a quantum theory that also treated collisions. Born and Jordan started from the classical theory of aperiodic electrical fields acting on a restricted periodic system and discussed induced probabilities of quantum jumps and employed a correspondence principle of movements in order to explain the Ramsauer effect. As Born explained to Einstein, the motivation for all this work was to understand collision processes with which Planck had mastered in Göttingen. Quote, chiefly, however, I'm interested in the also quite mysterious difference calculus that is behind the quantum theory of atomic structure. With Jordan, I'm systematically examining, though with limited mental effort, every imaginable correspondence relationship between classical multiply periodic systems and quantum atoms. This is a preliminary work for an investigation into processes of atomic collisions, quenching of fluorescence, sensitized fluorescence a la Franck, etc. Born and Franck were in ongoing discussions about collision processes from the very beginning of their Göttingen collaboration, and in their crucial years of the formation of matrix mechanics, which, however, was not able to cover these processes before wave mechanics came to its aid, Born was, in fact, alternately publishing with Jordan and Heisenberg on a new mechanics of matrices and with Franck on the formation of molecules from collision processes. With Franck, he explored the question of molecule formation and dissociation, and asked what role excitations and collision processes may play. Born showed that quantization has to distinguish rather slow nuclear motion and oscillations from the motion of the faster electrons, an idea Franck had already developed rather intuitively. It later became known as the Franck-Condon principle. The involved collisions of the second kind were at the heart of many projects by Franck's doctoral students. This sketch of the collaboration between Born and Franck is just one more example of the many strong experimental constraints that Born was fully aware of when he was formulating matrix mechanics with Heisenberg and Jordan. They illuminate that in the context of great efforts to experimentally capture all aspects of atomic collisions, molecular formations, and dissociation, it was self-evident for Born that any theory of quantum mechanics must address the question of collisions in scattering experiments. When Heisenberg celebrated the breakdown of a space-time description of single objects in the atomic realm governed by matrix mechanics as a revelation, Born immediately started to seek a framework that would allow the new impossibility of accounting for all mechanical quantities of the atomic scale to be married with the experimental evidence that was constantly gained from collision and scattering experiments performed in Franck's laboratory. For this reason, Born, Jordan, and Northeim still employed difference calculus to explain excitations of atoms in collisions, even with matrix mechanics at hand, which, however, was not yet capable to deal with this case. This example illustrates how the different lines of developments did not all meet exactly at a single point. It therefore appears rather straightforward that it was Born who proposed his statistical interpretation of quantum mechanics in 1926 and said that this step would hardly have been feasible without his collaboration with James Franck. As a tribute to Franck, he included in his paper also inelastic scattering, in this way providing a quantum mechanical description of the very Franck-Hertz experiment that is regarded as the first corroboration of quantum atomic structure introduced by Bohr. When Born went to the US in late 1925, he fully remained on this track of mastering collision processes. From this perspective, it is also clear that the often mentioned near miss of wave mechanics, when he and Norbert Wiener introduced operator techniques for quantum theory, does not do justice to his approach. The relation between energy and time appeared most important for collision processes. Direct observation of the position, however, was unfeasible. Therefore, they merely replaced the energy with the differential operator. Born's self-understanding as a physicist with strong attention to experimentation, which had developed to some extent after the war, probably also overshadowed his identity as a theoretician and as a mathematician trained by Hilbert and Minkowski. In any case, the collaboration between mathematicians and physicists in Göttingen, which was so close under Hilbert in the years before World War I, had somewhat loosened after the war when the experiment claimed some priority over theory. Thank you.
Thank you, Arne. Questions? We have a full 15 minutes. So, shoot. Yes.
Hello. Perhaps you, well, I am going to talk tomorrow, I think, about the work of Born in the United States. And we really do not know what was he really pursuing when he went there. What the relationship he found between the linear motion and the matrix mechanics he had previously. So perhaps you could give us some ideas of what's the relationship between the work he was trying to do with Wiener, searching for a quantum mechanical approach to linear motion, and the work on collisions that we really we don't know how to match.
Well, so what was the question?
Sorry. If the work that you have mentioned of Born in the United States with Wiener has, what's the connection between this work and the work on collisions? If you have some idea of how did it work?
Well, as I tried to explain from Born's point of view, it was a rather, say, natural way to try to find mathematical tools to describe better aperiodic processes, and for Wiener, clearly from a more mathematical point of view, it was learning about quantum mechanics. But clearly this collaboration was at a, say, crucial step, that the first formulation of matrix mechanics was just there without interpretation. And so, as I tried to demonstrate, that Born was trying to still make progress on various avenues, that there was this matrix calculus, but it won't help for aperiodic processes. There was this difference calculus which somehow worked for some problems, but only probably on a more or less, say, qualitative way. And so he was just being trained from integral equations and things like this with Hilbert, trying to, this is probably my pedestrian interpretation, trying to figure out whether additional mathematical tools may help. And clearly after Schrödinger's paper, then everything appeared, it's one moment very clear and clean cut. And so since all this machinery was around, probably, well, put it this way, I stressed the point that in a certain way, Born, say, diverged from Hilbert's approach of mathematizing. He turned to theory, he turned to more, say, qualitative discussion. It was discussing a lot with Frank. So that in a sense that Schrödinger's wave mechanics, it very strongly reminded him, well, what about just doing a little bit more mathematics?
Christian?
Yeah, thanks for a nice talk, Arne. So I certainly agree very much with you that like Born explored the manifold empirical constraints on quantum theory, especially with perturbation theory and so on that you worked on. My question is, do you see, especially in the experimental work that you looked at, do you see any point at which he basically zeroes in on something and says, okay, this is the most likely route, this constraint will lead us to a new theory, like the one he basically calls for in his 1924 article on über Quantenmechanik?
Well, I have to be honest and say I'm still not quite sure how to, say, better integrate the activities, the Frankfurt remains of experimental programs with his work on finding a new quantum mechanics. I can only show that they happened at the same time, that from first sight, very, say, strange routine, he would oscillate between Heisenberg and Frank and doing quantum mechanics and doing collision experiments or whatever, and then he has a student still working on molecular beams. The very weak interpretation is at least, well, he was made aware every day that there are molecular beams, that there is scattering. You have to solve this problem. Clearly, there was no, say, program of the same logic like his on quantum mechanics to somehow by discretization, by mathematical tools to find a new mechanics, that this experimental side would in the same way be a stringent or straightforward way. Probably one has more, it would be more interesting to study in detail. So what was James Frank's role? He also, since this is what I did not mention, Borns and Frank always say in recollections that they discussed every student paper together also, in a sense. So in taking this seriously, so Frank must have known everything about the progress in quantum mechanics, and Born has known everything about collision things and so on. So in a sense, the Frank perspective is not explored enough.
Martin?
Yeah, thanks for the talk. I really enjoyed this Frankfurt to Göttingen stuff. And I have two questions. The first is exactly in this Frank picture. I mean, where the molecular tradition comes from, I think is pretty clear now. But with the Ramsau effect, it's clearly Frank as the driving force. He borrows Hund to do this theoretical work, and he keeps on pushing Sponer and so on. And also collision processes with resonance and this quenching stuff is clearly rooted in Frank's work. My second question is, how do you see especially your work on point 3 in relation to the work of Yeong Song Im, who worked on basically the same stuff and pointed out, I think, to my mind, pointed out a similar thing.
Yeah, sure. This is a abridged version. I should have mentioned that I'm heavily relying on this seminal paper of Guanson Im, which for some reason have not got a greater reception. So this whole framework of, say, experimental constraints of quantum theory is there. Clearly, I have some different interpretations about some of these points I mentioned, and what is the main, say, insight I think I have gotten from combining Im with the institutional histories that I see where Born tries to push the Göttingen experimental and theoretical agenda and teaching and so on, and this also clearly relates to Hilbert's great effort to change Göttingen physics in a certain direction, so that it is both that you say have this history of ideas and problems, but also that you need the people like Klein and Hilbert, and to some extent also Born, who arrange things, who get positions created, who get a working group like in Frankfurt of Stern and Gerlach and Born and Bormann, or in Göttingen that he was instrumental to get Frank, or that he said, well, I can only come here if Frank is collaborating with me. To the first question, well, I'm not sure yet. In a sense, you might be right that probably we can make Frank bigger and Born smaller, or so, that Frank was pushing Born, and Born then was corresponding with Einstein and probably just relaying some insights. But clearly this is very difficult to figure out, and say from the result, clearly it was most important to have the discourse between Born, Hilbert, Einstein, and so on being connected with the experimental discourse. And so it is not that I try to make Born the only hero of the story, but rather to show that there's a big network, but he's actually one of the big players who created this.
Ariana with the last question of the day.
Thanks. Thank you so much. I'm trying to make more concrete your thesis or your suggestions, because speaking again about the Born-Wiener work, I think there was a lot of mathematical push. That actually it's a combination that Born was trying to follow up what Hilbert was doing with his operator thinking, but then mixing it up with experiment.
Yeah.
And I find your suggestion very, very important. And so my question is, do you think that the fact that in that work, Born was very much trying to interpret the variables physically? Yeah, you had here these theories, so that's time, that's energy. Would you connect that to his interest for experiment? That he, instead of doing, well, I'm doing mathematics, he was trying to read it physically?
Well, a quick answer would be that probably one can read this story that Born, and now it probably is up to your taste, either through his, say, technical, experimental physics involvement in the war, sound ranging, telegraphy equipment, and so on. He learned, say, the other part of physics, since he came from mathematics. So somehow he learned both in a war and in his Frankfurt position, more or less, say, the experimental side, where you clearly need to define what are you measuring and how do you relate it with some formula and with some notions. So in this sense, clearly, and this is why I find this is important for the quantum story, that the Born of 1919 is a very different person than the Born of 1913, say, in the relation between mathematics and physics.
Then thank you again, Arne, and cocktails.
Right, so just a couple of announcements. Well, congratulations for making it for the first day. You've deserved, I don't know, swimming the sea, whatever. Just a couple of things I didn't mention, that everything is being recorded. You might have seen a camera behind you. Of course, before uploading anything on any website, I will ask each one of you if you want that to take place or not. Second thing, I've just forgotten. But anyway, third thing, that the cocktail is served, is expected by past, so we have 20 minutes of resting or whatever. And at 7:30, when the cocktail starts in the same room we had the coffee break, the official photographer of the Donostia International Physics Center, which is not the guy who's taking pictures here, so he wants to come and take a whole picture of all of us, right? So we'll be with our first glass of champagne or whatever, and the guy will take a group picture of us. So please be there at 7:30, both for the food and for the picture. And just one last thing, that then you leave and go whatever you want, but we reconvene here tomorrow at 9:30, is it? Yeah. Okay, thank you.